Welcome everybody to another review by Mr. Moore. This video is going to be in preparation for 8.8T, which is going to be your modeling and solving equations with variables on both sides. This is a 7th grade TEKS equation review. Okay, so picking right up, everybody, one of the equations that we're going to be looking at today is the equation 3x plus 5 is equal to -7. This is a two-step, one variable equation. As you see there. So let's go ahead and do some just recaps of those steps. So the first thing that we would do is make sure that we are carefully writing down our equation. This is especially important if you are working from, say, a piece of paper, or you are doing one of my Google Forms for homework, or if you're working on a test or quiz, making sure that you're translating the equation that you see into the exact same format so that you can attempt to solve. Now, after you've done that, step number 1 is going to be for you to isolate the variable using the additive inverse. The next is going to be for you to undo the operation on the left by using the inverse operation. Once you get to your solution, of course, that means that you are solving for x and that you are interpreting your solution. And then lastly, it's going to be for you to do your check, making sure that you're always performing a check. So, picking right up, everybody, again, we're going to use the equation 3x plus 5 is equal to -7. So following along with the steps that we talked about a moment ago, okay, the first thing that we're going to do is go ahead and isolate our variable. The next thing that we're going to do is undo the operation with what is left using the inverse operation and then solving for x. So the first thing that I always like to do is to make sure that I have translated my equation again. Using just the same equation, and when I say translate, that just simply means that I'm going to rewrite it again in the exact same format. My students ask me, well, why do you keep rewriting it over and over again? I just want to make sure that I am looking at my equation in the right format and that I'm simplifying accordingly. Now, the language that I want to use now is that we are going to add -5 to each side. I'm going to separate what is on the left-hand side and what is on the right-hand side. So I'm going to add a -5 to both sides. Okay? And the reason that I don't say subtract is because I can add negatives, I can add positives, so that's the language that I want to use. Once I do that, everybody, I am creating 0 pairs, so that will equal 0. That leaves me with 3x on the left-hand side. Okay? 3x is equal to a -12. Okay? And the next step tells me that I want to undo the operation that is there on the left. So again, I'm left with 3x is equal to -12, but I'm not quite done yet. So because I know that 3 times x is multiplication, the way that I undo that operation is by dividing both sides by a 3. Okay? And when I do that, I'm given my solution. Okay, and I get a solution of -4 because when I divide a -12 by a +3, I'm left with a negative number. Now, the way that I interpret my solution, in this case for an equation, there is one solution always to an equation, and that answer in this case is going to be x is equal to -4. But I don't stop there. I still want to go ahead and do my check. I'm going to go back to my original problem, which was 3x plus 5 is equal to -7. That's where I come in again, everybody. Okay, with that, putting down my equation again, I'm going to then substitute in for my value of x that I have, that is -4. I have a -12 plus 5 is equal to -7. Now remember, everybody, when I am looking at combining two integers that again is +5 and -12, I'm looking for the integer with the highest absolute value. I'm taking that sign, which in this case is a negative. I'm finding the difference between these two numbers, 12 and 5. That is 7. So again, I'm left with -7 is equal to -7. Is that statement true? Absolutely, it is. Okay? Now let's flip the coin, everybody, or flip the side of that coin. We're going to go over to inequalities in this case. So I'm going to use an inequality that looks very, very similar to this, everybody. This is going to be 3x plus 5 And where I'm going to change this, it's going to be less than or equal to -7. Less than or equal to -7. So that's the exact same one that I used before. And the only difference is that I used an inequality symbol. Now, again, I'm going to need to interpret my solution and ask myself, how many possible solutions can there be? In this case, there are an infinite number of solutions, but I'm going to narrow it down to an example solution set. Okay, so there are infinite solutions, and I'll show you what that looks like in just a moment. All right, in this case, everybody, I'm going to do the exact same thing, except this time, like I said, I have that inequality symbol. I'm going to draw myself a line to separate what is on the left-hand side and on the right-hand side. Again, I'm going to add a -5 to both sides because I am starting off by using the additive inverse. I want 3x by itself. I want to isolate that variable. Remember again that is going to create a zero pair, which in this case 3x is less than or equal to -12. Remember, when I combine two integers, these two negatives together become more negative. That's not multiplying them or dividing them. What it is combining them. Some people like to say I'm adding them together. I like to say the word combine because sometimes students get hung up on the words adding and subtracting. So I'm putting these two together. I'm putting a -7 and I'm putting a -5 together. That's a -12. Okay? Just like in the previous part that I have there, I have 3x is less than or equal to -12. I'm going to undo the multiplication here by dividing each side by a 3. Okay? When I do that, I am left with what, everybody? I'm left with x is less than or equal to a -4. Okay? The reason that is, everybody, again, -12 divided by 3 is -4. The only thing that's different this time is that I have an inequality symbol that's less than or equal to -4. Now, what is a possible solution set? Let's come up with 3 different possibilities for my solution set. The 3 different possibilities I want to figure out. X can be less than or equal to -4. So what are some numbers in my solution set? So this is only an example solution set that could satisfy this statement. So when I say satisfy the statement, I simply mean what could they be? Okay, so x is a number that is less than or equal to -4. So if some number is less than or equal to -4, less than or equal to -4, it stands to reason. It could be -4 because remember, this value must be less than or equal to -4, so that -4 works. What about -5? What about a -3? Now this is something that's come up in class. I had several students that said -3. Why can't it be -3? Well, again, x can't be -3 because x has to be less than or equal to a -4. And in this case, -3 is greater than -4. So the closer that I get to 0, that number gets bigger and bigger. So that answer actually could be -6. So because -6 is less than a -4. So my possibilities, and again, these numbers can be infinite, but it can be -4, -5, -6. Okay. So for our check, let's just go ahead and use -5, everybody. So again, I'm going to go back to the original problem. Excuse me, everybody. Thinking one thing and writing another. It should be +5 or +5. I'm going to do 3 times -5. Okay. And what I do when I substitute in, I'm just going to go ahead and start simplifying. So -15 plus 5 is less than or equal to -7. When I combine these two, -15 and 5, that gives me -10 is less than or equal to -7. Now ask yourself, is this statement correct? In fact, it is, because -10 is less than -7, less than or equal to -7. Okay, so it's not equal to, but it is less than or equal to. Okay, that's a conditional statement, everybody. Anyway, that was just a very, very quick tutorial on review on our two-step inequalities and equations. I hope this was helpful. If it was, go ahead and give me a like on the video. Otherwise, you may get with me in class, ask this question, or you may come to a tutorial session. Thank you, everybody, and I'll see you soon.